Okay, so now what we are going to see is an example to illustrate how each process can send a message to a multicast group, and also the senders are kind of part of the multicast group now, so they also receive the message that they had sent to the group. So basically, there is a multiple senders, multiple receivers. So a process can serve both as a sender as well as a receiver. So each process sends a message, and that message is received by all the processes, including this process. Okay, so again, let me repeat. So each process can send a message to the group as well as receive messages for the group. So each process will send one message that will be received by all the members of the group, and since the sending process is also a member of the group, it will also receive that message. Okay, so let's see the code for that. So you can have both the sending and receiving functionality in one single program Java file, but you'll have a separate thread for receiving. Why we need a separate thread for receiving? Because the number of times we need to receive depends on the number of senders that are out there. So we don't know that beforehand how many people are part of the group and how many senders are out there external to the group either. So we typically run the receiving thread in this case in an infinite loop, okay, and let it be ready to receive any number of messages that come for the group. Whereas according to our example here, we are going to send only one message, right? So you don't need to run the sender in a thread or in a loop. You can just run the sender in the main program, because it's just going to send one message, and other than that, you're not going to send anything from each process. So I call multicast sender receiver and have the main function, and essentially kind of spawn the read thread or the receive thread, and the receive thread is implemented in a separate class, whereas the sender receiver thread mainly implements a sending uh, process. Okay, and also you should remember that as we have been doing, the receiver should be started first, right? So here we have multiple processes, and everyone should be able to receive the messages, right? So which means your receive thread should be started first. Okay, so receiver should be started first. So you should make sure that all the receive threads are started, because you're implementing receive functionality in a thread. Okay, so all the receive threads should be started before you send any message. So I will start a process, and that will start its receiver thread, but then I have to go to another terminal and start that process's receive thread. So which means once I started, for example, this is a program which when we compile, this is how it will look like. So you see here, this process has been started, okay, and it is ready to send a message, but I have not started the other processes, right? So I should go to all the processes and start them. So until then, I should not let this process or even any other process. So even if I want to start this process has started, but the other processes have not started yet, or some of the other processes have not started yet. So this process or any process should not be able to send a message until all the receivers are started. So that's why I say hit return to send a message, which means I have to code accordingly so that it recognizes the return thing or the pressing the enter key, and only after that the process should be able to send a message. Okay, all right. So this is the port number for the multicast group. This is the IP address. So now this is a send socket for the multicast group. So I don't need to open it on a specific port number. It could be opened on any port number. So I let the operating system to decide that. So now I create a thread, an instance of the class read thread, and I pass the group multicast group IP address and the port number as arguments for that constructor, and then I call the start method on that read thread. So let's see what the read thread does. So the read thread, like we saw in the previous summation concurrent server case, it extends the class thread, and here I have some member variables and objects. So this is the IP address, and then the multicast port integer, and the maximum message length that you could receive is 100 bytes or 100 characters. So this is the read thread constructor that basically initializes the IP address and the multicast port that we pass as argument through this constructor for the read thread class. And then I have the run method. So the run method is essentially the same thing that we saw in the previous multicast example to receive a message. So I now open a read socket as a multicast socket on this multicast port number to which every process will be sending the messages. And now I join the I let the multicast socket, the read socket, to join the group, which is what is the group? The group IP address that we instantiated here and then passed as the argument here to the constructor, and so that should be this group. So now we run an infinite while loop because we don't know how many processes will be sending their messages. So we run an infinite while loop and we create a byte array of length 100 bytes, and this is the datagram packet, and I'm going to basically get prepared to receive a packet. This is the message and the length of the message, the IP address, multicast IP address, and the port. And then I call the receive method on the read socket, and I pass the datagram packet as the argument to the receive method. So this happens. So this is a blocking call. So someone should send a message to the multicast group, and this process will receive that packet to the multicast group, and then once it receives it, that message will be stored in this byte array, and I can call actually there's another thing that you could do. You can also call packet.getData in the there's a method that lets you to do that in the datagram packet class. So this will get you the byte array, and that you can create as a string, and you can print the contents of the string. Okay, and this runs in an infinite loop. So after you process the message from one particular process, after you basically process one datagram packet, you can go back to the loop and start waiting for another datagram packet. So now let's see what the sender does. Okay, so you start the thread, and this is what you should do when you start each of these processes, like we have been doing here. You should start because this is sequential in this case, right? You initialize all these things and then start the read thread. So all the read threads should be started. Okay, and then I basically pass the process ID as command line argument, and the message I want to send as command line argument. So each process can have its own ID. Just our own ID is the operating system will of course assign its own process ID, but just for our multicast within our multicast group, just for identification purposes, we will assign the ID for the process. It may not be needed depending on the situation, but we can assign an ID for each process, a unique ID for each process, and input a message that you want to multicast to the group. So I'm kind of stitching together the two inputs, and I'm saying the message from process number, the process ID that I input, and this is the message. So the process ID and the message. So then I'm extracting the bytes from that multicast message string, and I'm converting my datagram packet object, and by passing the message, the message length, and the IP address of the multicast group and the multicast port number. So I have basically readied my packet, so it is ready to be sent, but I'm not sure whether I have started all the receivers. So I should make sure I go to all the terminals, start all the processes, which means I have started all the receivers. Then I should come back and hit enter in each of those processes so that now they can send the message. Okay, so when I press enter, it's a kind of input I am passing, and that I'm using the buffered reader, and it is now reading from the input terminal input system.in. So that enter key that I press is captured in this read line method. Okay, so you can call the read line method in the buffer reader class on this object, and the enter key that you press is basically a dummy input, so I'm not capturing that into any value, so I'm just calling the readline method to capture that enter key press. Then I call the send method on this multicast socket, and I send the packet, and I don't need to do anything else on the send socket for the multicast group. So I just close the send socket for the multicast group, and the packet has been sent to the group, so it will be received and printed, okay, at each process. So this is what happens, that every process sends a message after all the receivers have been started. Okay, so let's try to run it. Let me stop this. So this is an running infinite loop, right? So you press Ctrl C to stop them. Okay. Okay, so let me just compile this. Okay, so now let's run this. So I need two arguments. So what are the two arguments? I need the process ID and the message that I want to multicast. Okay, so the process ID is say 1, and I am sending or process 1 is sending a message, anything that you could send, 100 bytes. Right? Let's put it like this. Sending this message from process 1. Right? So the receive thread for this process has now started, but we have not started the receive threads for the other processes. Each of this is a process now, right? So we need to go to the other terminals and start them. Start means once you start the program, program execution is a process. So receive, the whole program starts, and then we have to start the receive thread. Okay, so for this particular process, the receive thread has started. Okay, so we have to do that same thing for everyone before we press enter in any of these terminals, because if you press an enter, it means it will send the message, but there won't be any receivers out there to receive other than this particular process, right? So we need to start the receive threads at all the processes before we can send any message. So this is process 2. I'll just make some small variations. Okay, and then in the message, some small variations that are noticeable. Sending the message, sending the say multicast message from process 3. Okay. Let's say call data. I'll take as data from process number 4. So now I can press the enter key. You could press it in any order. So I press 2. So message from process 2 is received at all the processes, receive threads. Then press this. So everybody will receive message from process 4. Let's press 3. Process 3's message goes to everyone. Now we'll press process 1. Process 1's message goes to everyone. Okay. And the customized messages from each process are clearly visible, right? Alright, so it's running infinite loop, so you should press Ctrl C to stop them.